we will study first the structure of the lymphatic system. Please take note, lymphatic systems is like the arteries and veins, okay? Because it intermingled with the arteries and the veins. The only difference is the lymphatic vessels in the lymphatic system. So they consist of nodules, lymph nodes. So there are nodules along the way, or nodes, or we call it lymphatic nodules, or you can call it also lymph nodes. So there's so many words, and it connects with each other, but it is one way. It is a tube that has only one-way flow. Unlike the arteries and the veins, they are interconnected with each other through the heart, right? So that is the interpretation of our lymph. So please remember that the lymph is the fluid. So it's not blood, okay? It's a fluid. It's an interstitial fluid. It's coming from the extracellular matrix. Between your cells are fluid. So it comprises like 15%. So that 15% of fluid that is not reabsorbed through your capillaries, it stays under tissue. So the tissue now has extra fluid. Then the lymph vessels are the one taking it out and bring it to the lymph vessels, and then bring it back to the heart in the vena cava. So take note of that. So lymphatic system has to function very well. Otherwise, the body will have edema. You know what's edema? Edema, when there's swelling of the feet, or swelling of the legs, or swelling of the arms, so on and so forth. Okay, so what are we going to study here? Structures and function, location, the composition of the function, the circulation of the lymph. Spleen is the largest lymphatic organ, okay? And then the thymus, we already studied the thymus, lymph nodes and nodules, and lymphatic vessels. So this is lecture 31, mostly anatomy, no physiology at this point. Okay, so lymphatic system, it connotes also immune system, because the defense mechanism to prevent diseases in our body is in your lymphatic system. So antibodies circulate, leukocytes circulate in the lymphatic system. That's why it's also called the immune system, because this is our defenses of diseases. And sometimes it's called the fluid homeostasis, because it's the one that will try to balance the fluid between the cell, inside the cell and outside of the cell. So, okay, so two main components of the lymphatic system. One are the lymphatic vessels. We will study the trunks of the lymphatic vessels, just like when you study your arteries and the veins, okay? And then the tissues and the lymphoid organs. So there are two categories there. So the lymphatic systems are systems of blind-ended tubes, okay? So very different from arteries and the veins, okay? And it says here the lymphoid organs or follicles are composed of tonsils. You're familiar with tonsils, right? So that's a lymphoid organ. Lymph nodes all over your body. It's more than 400 of them. Spleen, the biggest one, and then the thymus, where the maturation of the T cells occur, right? You know that, yes. Okay, so if you look into the drawing, so the green portion is your lymphatic vessels. It's all over your body, from the foot down to the brain and to the arms and to the legs and everything in your body. So those are the green ones. And then the big organs, the lymphatic organs are also emphasized. Tonsils are here, thymus is here, above the heart, you have the lymph nodes all over. Your spleen is on the left side of your stomach. And just, try to cover up your stomach. And then we have the MALT, or mucosa associated lymphatic tissues found inside large intestine, because these are also rich in antibodies, or they're also rich in leukocytes. So when the bacteria is in your large intestine, it can eat them. So not only these, the MALT, it has in the reproductive system, it has in the respiratory system, and everywhere in your body. Of course, you have the large intestine, the small one, you have the stomach, the heart, and then the vessels. Okay, so functions of the lymphatic system, 1, 2, 3. Okay, so first is your regulation of the fluid. Again, the fluid inside the cell and in the fluid outside the cell. So if there's a lot of fluid outside of the cell, so the lymphatic vessels take it out and bring it back to the vena cava, to the heart. Okay. And then you have absorption of diet fat. So these lacteals or chylomicrons are products of digestion of fats. These are big molecules. It cannot pass through capillaries. Okay, so it doesn't go directly to the blood, to the bloodstream. Instead, it goes into the lacteals. You call it lacteals. It's found in the small intestine. When you eat fat, right, then it goes to your small intestine. The small intestine absorbs the food, your proteins, your amino acids, your glucose, but the fat does not go to the bloodstream. It goes to these special lacteal, and then the fat goes there. The fat now is a little bit smaller than your fatty acids or glycerol that we studied. So it's called already chylomicrons. So all this fat or chylomicrons go to your lymphatic vessel, circulate, and then it is brought back to the bloodstream through the vena cava. So through the, of course, through the lymphatic vessel. Immune functions, because everything, your antibodies are there, your neutrophils, your phagocytes, your macrophage, basophils, the one that we studied, monocytes, lymphocytes, and so on and so forth, is found in the lymphatic system. Okay, so regulation of the interstitial fluid. Look, so we have like 2 to 4 liters per day of plasma. Plasma is the liquid portion of the blood, right? So, but then, if all of this does not return to the blood when it is in the tissues, 50% remains in the tissues. So it is taken by the our lymphatic vessels. Dietary fats, this is very important word, please. Remember this, chylomicrons, huh? Don't sleep on this word. This is very important. This is classic word, okay? So these are the fats, globules that go into the lacteals, okay? And it will enter into the lymphatic vessels through the blood. Immune function, because so many leukocytes, and then please remember the thymus is the T cells mature, right? That's what we have in our blood and blood vessels. Okay, so lymphatic vessels and circulation. So we have at least many types of trunks. Just like what we studied, marginal artery, we studied the aorta, we studied the pulmonary artery. So we have also some branches of lymphatic vessels. So it has two very important trunks, okay? The big ones. So the lymphatic trunk or lymphatic duct on the right side, okay, of the heart, and then the thoracic duct on the left side, okay? So these two ducts, big ducts, go into the brachiocephalic vein, to the subclavian vein, and then join the blood in the right atrium. Okay? So these are the two. So memorize these. Lymphatic duct, right, and then thoracic duct, left side. So write it. Okay, so how many trunks do we have? We have 9 major trunks. Right and left lumbar, you know where's lumbar, right? Okay. Then we have the intestinal tract inside the abdomen. And then we have the right and left jugular trunks. And then we have the right and left bronchomediastinal tract in your thoracic cavity. We have the right and the left subclavian trunks. This will join the brachiocephalic vein, then going into the right atrium. Okay? And then you have the intestinal and lumbar trunk, which drains into a swollen or bulging lymphatic vessel. Again, do not forget this word, cisterna chyli. It's like the chylomicron cisterna chyli. Okay, so if you look here, so this is your superior vena cava, right? Blue. So your inferior vena cava here, and if you look, these are the vessels that will bring the blood or the lymph into the blood. Right side is your lymphatic duct, left side is your thoracic duct. Okay? So here is sternochyli. Pointing again. That's your sternochyli in the lumbar area, huh? Inside the abdomen. So that's sternochyli. Trunks on the left side of the lower body drain into the thoracic duct, which is on the left side. So coming back, so this is your left side, that's your thoracic duct. So that big trunk there, this is sternochyli, go to the thoracic duct, not in the left, which is your lymphatic duct. Got it? Okay. So right lymphatic duct drains the junction of the right internal jugular and right subclavian veins down into the brachiocephalic veins to the right atrium. Okay, so again, so the main lymph trunks and ducts, so drainage, right lymphatic duct, okay, and then you have the left thoracic duct. Don't forget those two names. Do not interchange it. Okay, now this picture shows where the lymph fluid goes. So on this little side here, on the right side, that's right lymphatic duct. That's the only portion where the lymph goes. And then on this bigger portion, that's where your thoracic duct drain the blood to the right atrium. So area of yellow, area drained by right lymphatic duct, area greenish, area drained by thoracic duct. Okay? So thoracic duct again, left side, lymphatic duct again, right side. Okay? So this is anterior. So increasing like this is right, this is left. So the question is, when I give you a question on the test, which is a smaller area? Lymphatic duct or thoracic duct?
Lymphatic.
Lymphatic duct. Okay. So, okay, now, so let's go here. Lymphatic begins at the tiny capillaries surrounding the beds. So it's blind in this tube again. So again, the chylomicrons are there in the small intestine. Then the word lacteals again is there. So if you look at the tissues, you have your arteries, arterioles, veins, venules, then capillaries. The green one is your lymphatic vessels. Okay? Okay. Or lymphatic capillary. Okay? Okay, very good. Now, if we said a tube that has an end, one-ended tube, so that's how it looks like. So this is one cell, one cell, one cell, one cell, one cell. This is the space, or interstitial fluid, or extracellular space. This is the fluid, the 15% that drains into the green lymphatic vessel. Look at the arrow, only one direction. And these are valves. It closes, so there's no backflow. Okay? If something is wrong with the lymphatic vessel, water here stays, water here stays, water here stays, so you blow up. You're bloated. It could be in your stomach, or it could be in your thigh, it could be in your leg, it could be your toe, it could be somewhere in your axillary or your face. Okay? It could be localized somewhere in your body. Or it could be generalized.
Where the water gets that from?
Huh?
The heart? Where the water gets that from? Heart?
Interstitial fluid. Don't you know we studied the ICF and the ECF? Yeah. Okay, so lymphatic vessels and lymph circulation, so you have always this macrophages going around. So the name lymphedema is swelling. So that's now the disorder, this disease, when lymphatic vessels are moved or blocked. So you will have a problem, a disorder called lymphedema. So there is a blockage there is a blockage, and the water does not circulate into the system. Look at this lady. This is a woman with lymphedema on the right arm. This is normal, that is not normal. So that will happen if the lymphatic system is not functioning very well, because the fluid stays in the interstitial spaces. So you know what I mean, what's interstitial, right? It's the extracellular space. Okay, so let's go now to the organs, the lymph organs. You know now already the lymph circulation. So predominantly tissue of the lymphatic system with reticular fibers. We have studied this during our tissues of the body, right? So the reticular fibers, which is partly very important on the lymph, in the lymph nodes or in the lymphoid tissue, because it's the reticular fibers. It is like a mesh. So when there are macrophages there, when there are bacteria there, it's just trapped into that mesh, and then so our macrophages can kill the bacteria on it. Okay, so an example, we know already macrophage, right? Right?
Yeah.
Correct?
Yes.
Yes.
Okay, so you know the meaning. So you have the reticular fibers, you have the B and the T lymphocytes, you already know, right?
Yes.
Okay, and then dendritic cells, not yet? Yeah, and then reticular cells, you know those words, right? Okay, so in the lymphoid tissue and organs, mostly you have some cells, leukocytes, dendritic cells, and reticular cells. Okay, those three of them. So the leukocytes, of course, you have the macrophages. Macrophages come from monocytes, right? Or neutrophils or whatever. And then the B lymphocytes are coming from the lymphocytes. That's a B cell that will produce antibodies. And then T cells of lymphocytes are coming from the lymphocyte cell. So dendritic are spiny cells, yes. It assembles like the dendrites of the neurons, and then it has several of them rolling around the lymphatic system. So, of course, the reticular cells is part of our tissues, and it's all over the spleen and all over the lymph nodes. So, this is the MALT I'm talking about, found in the gastrointestinal tract, respiratory passages, and genitourinary tract. It has also like many functions, because mouths are composed of B and T cells. These are lymphocytes, okay? And then it is specialized also B cells, dendritic cell, macrophage. So there are specific names where the mouth is, like Peyer's patches. Peyer's patches is found in the intestine, in the ileum of the intestine. What's ileum? Ileum is the third part of this small intestine. You have the duodenum, you have the jejunum, and the ileum, the last part. So if the bacteria over there, so it can the Peyer's patches is important because it can kill the bacteria when it's not needed in your small intestine. Tonsils, of course, here, and appendix. You know where is your appendix, right? Mm-hmm. So this is part of the immune organ. So it is hanging like a finger on your cecum, on the first part of your large intestine. Okay, so found in the last portion is called ileum. That's your Peyer's patches. So this is the ileum part. This is your colon, ascending, transverse descending. You have your sigmoid flexure, your rectum. So that portion there is your Peyer's patches. Tonsil, you have three types. You have pharyngeal, palatine, and lingual. So if you look here, so if there's inflammation on tonsillitis, so your tonsils are compromised, there's a lot of bacteria over there. So it's inflamed. So we call that tonsillitis. So here, so your pharyngeal, palatine, and lingual. Appendix. Appendix is hanging on the cecum. Cecum is part of large intestine. So it is also rich in macrophages. So inflammation is called appendicitis, right? Okay, so that's the one, hanging. Okay, lymph nodes. Lymph nodes are all over the body. So we have axillary lymph nodes. Where's your axillary? Your armpit. Where's your cervical? Here, your cervical vertebra, right? Inguinal. Where's your inguinal? Here, right? Mesenteric inside the abdominal cavity. So axillary, cervical, mesenteric in your intestinal cavity, and then your inguinal is over here. Okay? So anatomy of the lymph nodes. So the lymph nodes, in between those are the lymphatic vessels. So if there's a lymph node here, another lymph node here, another. So the lymph flows, and then each flow there's a lymph node. It's like a resting area, right? And then every now and then, so yes, the lymph flows all over those vessels. So when the lymph flows inside the lymph node, okay, so it is called afferent lymphatic vessel going into the lymph node. So in that case, there might be so many bacteria, and then our leukocytes, our macrophages are waiting for the bacteria. Sometimes they kill it inside the lymph node. Okay, when the lymph gets out of the lymph node, clear, right? And you call it efferent lymphatic vessel. So it's really sometimes opposite. This is the afferent lymphatic vessel. This is the efferent. Okay, going out efferent, coming in is afferent. Got it? Okay, so this is an example of a nodule or a lymph node that has got mid-sagittal. So you have your afferent here. On the other side is your afferent. Okay, and those are cells that we have those medulla, we have those cortex, we have a lot of cells in there. Okay, let's go to the spleen. Largest lymphoid organ and protects from blood pathogens. Why? Because we have so many B cells, T cells stored in there, or we have so many leukocytes, white blood cells stored in there. Aside from the graveyard of your RBC, so it is a storage of many white blood cells. So located on the lower side of the upper left quadrant of the abdominal pelvic cavity. So purple brown organ, the size of a barb. So yes, big one, like a big tongue. So here, this one, that's your spleen. So there's a red pulp and a white pulp on that. So to make it simple, the red pulp has lots of red blood cells. The white pulp has lots of white blood cells. Okay, so it contains macrophages in white pulp. It contains erythrocytes in red pulp. Okay, and it has lots of leukocytes and dendritic cells as well in the spleen. Okay, so this is the microscopic, the red pulp, and then you have your white pulp. So it distinguishes the blood elements inside of it. Okay. Of course, it has a central arteries, T cells and B cells are a lot there containing inside of it. So we call it sinusoids. Sinusoids are spaces in between the cells. Remember our liver, it's a lot of sinusoids where the bile is produced. It's the same with the spleen. So we have those sinusoids, very leaky capillaries, so that it's easy to transport all of these molecules or substances. So pathogens encounter macrophages and dendritic cells in the sinusoids, and they can kill them, okay, instantly. Thymus. Thymus is encapsulated organ, so just above the heart, okay? And you see this, if these are the lungs of the right lobe and the left lobe, you have the thymus there, okay? So you zoom it, that's how it looks like in adult thymus. So the newborn, if you look here, it's big one. So a newborn is a big thymus. When you become adult, it's shrunk a little bit, but still you have enough supply of T cells. So T cell supply does not diminish because when you were a kid, so there's a lot already of number of T cells. So it's not that when you become adult, you are deprived of T cells. No, it's still the same, but it just shrunk when you're adult. Okay, so thymus, it houses the T cells. It matures and stores there. Only the T cells, not the B cells or not the red blood cells. We studied that right before. Yes. So a thymus doesn't trap pathogens like the spleen or lymph nodes. It just is a very important place to mature, to T cells to mature there and store there. Okay, so this is an adult thymus, already very small. A young thymus is still newborn compared to the adult. So okay, so after age 12 to 14, this is the puberty age. So begins to atrophy. Atrophy means shrink and replaced with fat. So by age 65, so it's 2% of the size of the original size of the thymus when the baby is born. So very small. So, but immune function does not decline due to the number of T cells. So if I give you an example like true or false, that should be false, right? So T cells are still okay in number. Okay. So consists of subunits of thymic globules. Yes, again, we have the cortex and medulla, just like any other nodules. So it is packed with T cells. Yes. Okay. So we finished the anatomy of the lymphatic